Imagine for a moment you're gazing at the night sky, contemplating billions of stars, when suddenly you notice something extraordinary. While you observe a few hundred luminous points, at this very moment, artificial intelligence algorithms are analyzing data from space telescopes and discovering planets, stars, and even black holes that no human eye has ever seen. In just one night, these machines processed more astronomical information than all of humanity has managed to analyze in centuries of observation. And the most impressive part, they are finding patterns and making discoveries that our brains simply couldn't perceive. Today, we're going to explore how artificial intelligence is revolutionizing our understanding of the cosmos, revealing cosmic secrets hidden in mountains of data that, without these thinking machines, would remain forever invisible. You'll discover how algorithms have already identified thousands of exoplanets, how AI is mapping the universe's dark matter, and how, in the not-too-distant future, machines might make scientific discoveries completely autonomously. Prepare for a revelation that will change your perspective on who is truly exploring the universe. Hello, cosmic explorers. Welcome back to Cosmic Frontiers, where we transform the mysteries of the universe into accessible knowledge. We're on an incredible journey towards our first 1,000 explorers, and each one of you is fundamental to this adventure of cosmic discovery. Let's begin our exploration by understanding the magnitude of the challenge we face when trying to comprehend the universe. Imagine you have a library with trillions of books in front of you, but each book is written in a different language, with complex codes, and you only have one human lifetime to decipher them. This is exactly the situation for modern astronomers. Our space telescopes, like Hubble, James Webb, and Kepler, capture astronomical amounts of data every day. To give you an idea of the scale, the Kepler Space Telescope, during its 9 years of operation, collected data on over 530,000 stars simultaneously, generating petabytes of information. 1 petabyte is equivalent to 1,000,000 gigabytes, meaning you would need approximately 20,000 home computers to store just 1 year's worth of Kepler data. For decades, human astronomers analyzed this data manually, a Herculean task that drastically limited our capacity for discovery. It was like trying to find specific needles in a haystack the size of a continent. But then something revolutionary happened. Artificial intelligence entered the scene, and with it, our cosmic exploration capabilities took a quantum leap. The first major revolution came with the discovery of exoplanets, those distant worlds orbiting other stars. Traditionally, finding an exoplanet was an extremely laborious process. Astronomers needed to observe a star's brightness for long periods, looking for minimal dips in luminosity that could indicate a planet passing in front of it. Imagine trying to detect a flea flying in front of a lighthouse miles away, and you'll get an idea of the difficulty involved. In 2017, researchers from NASA and Google developed an artificial intelligence algorithm called Astronaut K2, based on neural networks, to analyze data from the Kepler telescope. The results were spectacular. Within weeks, the AI identified 2 new exoplanets in the Kepler 90 system, making it the first known star system with 8 planets, matching our own solar system. But the most impressive thing was not just the discovery itself, but the speed. What would have taken human astronomers years to analyze, the AI managed to process in a matter of hours. Christopher Shallieu, a senior software engineer at Google AI, explained that the neural network was trained to identify the subtle patterns in luminosity data that indicate the presence of a planet. It's like teaching a machine to recognize the unique signature each planet leaves when it passes in front of its star. Since then, similar algorithms have identified thousands of exoplanet candidates, many of which have since been confirmed by follow-up observations. But artificial intelligence's contribution goes far beyond discovering new worlds. It is literally mapping the invisible architecture of the universe. About 85% of all matter in the cosmos is composed of something called dark matter, a mysterious substance that does not emit, absorb, or reflect light, making it completely invisible to our telescopes. It's like trying to map an entire city by observing only the shadows that buildings cast, without ever seeing the buildings themselves. Traditionally, astronomers inferred the presence of dark matter through its gravitational effects on visible matter. They observed how galaxies moved, how light bent as it passed through regions of space, and through complex calculations, they tried to deduce where dark matter should be. It was an incredibly time-consuming process subject to subjective interpretations. Then, in 2019, an international team of researchers developed a deep learning algorithm capable of mapping the distribution of dark matter with unprecedented precision. The algorithm, trained on computational simulations of the universe, learned to recognize the subtle patterns in the distribution of galaxies that revealed the presence of invisible dark matter. It's as if the AI had developed a kind of cosmic X-ray vision, capable of seeing through the darkness of space. The results were revolutionary. The algorithm was able to create three-dimensional maps of dark matter on cosmic scales, revealing a complex network of invisible filaments connecting galaxies across billions of light-years. This cosmic web of dark matter is like the invisible skeleton of the universe, determining where and how galaxies form and evolve. Niall Jeffrey, a researcher at University College London and one of the algorithm's developers, compared the process to trying to reconstruct the shape of a sponge by observing only the soap bubbles that form on its surface. The AI managed to perform this reconstruction with a precision that surprised even the researchers themselves. But perhaps one of the most fascinating applications of artificial intelligence in astronomy is in the classification and analysis of galaxies. Our observable universe contains approximately 2 trillion galaxies, each with unique characteristics that tell us stories about cosmic formation and evolution. Manually classifying this astronomical number of galaxies would be an impossible task for any human team, no matter how large. In 2007, astronomers launched the Galaxy Zoo project, a citizen science initiative that invited volunteers from all over the world to help classify galaxies. In images from the Sloan Digital Sky Survey, the project was an extraordinary success, with over 200,000 volunteers contributing to the classification of over 1 million galaxies. But even with this impressive workforce, the process was still slow and limited by the human capacity to process visual information. Artificial intelligence completely changed this scenario. Computer vision algorithms, trained on classifications made by Galaxy Zoo volunteers, learned to identify and categorize galaxies with extraordinary speed and precision. These algorithms can distinguish between spiral, elliptical, and irregular galaxies, identify galactic mergers, detect structures like central bars and spiral arms, and even estimate the age and mass of galaxies. Mike Walmsley, a researcher at the University of Oxford, developed algorithms that not only classify galaxies but also quantify the uncertainty in their classifications. It's as if the AI not only said, "This is a spiral galaxy," but also, "I'm 95% sure it's a spiral galaxy, but there's a small chance it's something different." This self-assessment capability is crucial for scientific research, as it allows astronomers to focus their efforts on the most promising discoveries. Now, let's explore one of the most exciting frontiers of modern astronomy: the detection of gravitational waves. These ripples in the very fabric of space-time were predicted by Einstein over a century ago, but were only detected for the first time in 2015 by the LIGO detectors. Imagine space-time as the surface of a perfectly calm lake. When two black holes collide somewhere distant in the universe, they create waves on this surface that propagate at the speed of light. When these waves reach Earth, they are so subtle that they cause the LIGO detectors to contract and expand by an amount less than 1,000th the diameter of a proton. Detecting these tiny ripples amidst background noise is like trying to hear a specific person's whisper in the middle of a crowded football stadium during the World Cup final. LIGO detectors continuously generate data, and finding gravitational wave signals in this sea of information requires extremely sophisticated algorithms. Artificial intelligence has revolutionized this search. Deep learning algorithms have been trained to recognize the characteristic signatures of different types of cosmic events: black hole collisions, neutron star mergers, and even still unknown events. These algorithms can process data in real time, alerting astronomers to potential detections within minutes. Daniel George, a researcher at the University of Illinois, developed algorithms that not only detect gravitational waves, but also estimate the properties of the objects that created them: their masses, velocities, distances, and even the direction of their orbits. It's as if the AI could hear an invisible cosmic symphony and from that music, reconstruct the entire orchestra playing it. But perhaps the most revolutionary aspect of artificial intelligence in astronomy is its ability to make completely unexpected discoveries. Unlike humans, who often look for patterns we already expect to find, AI algorithms can identify correlations and patterns that would never occur to a human mind. A fascinating example of this happened in 2020, when researchers at the University of Cambridge used machine learning algorithms to analyze data from the Gaia Space Telescope, which is mapping the positions and movements of over 1 billion stars in our galaxy. The algorithm identified groups of stars that moved in a coordinated way through the Milky Way, revealing evidence of ancient galactic collisions that happened billions of years ago. These discoveries are like finding cosmic fossils, remnants of dramatic events in our galaxy's youth. The algorithm was able to identify patterns in stellar movements that tell the story of how the Milky Way grew and evolved, absorbing smaller galaxies over billions of years. Without AI, these subtle patterns would remain forever hidden in the complexity of the data. Vasily Belokharov, one of the researchers involved in the project, compared the process to trying to reconstruct the history of a city by observing only the movement patterns of its inhabitants. The AI was able to identify neighborhoods of stars that moved together because they were born in the same satellite galaxy before being absorbed by the Milky Way. Now, let's look to the future and imagine how artificial intelligence can completely transform our approach to cosmic exploration. We are rapidly approaching an era where algorithms will not only assist astronomers, but will be able to conduct scientific research completely autonomously. Imagine space telescopes equipped with AI that can reformulate their own missions in real time. If an algorithm detects something interesting in a specific region of the sky, it could automatically redirect the instruments for a more detailed observation, adjust observation parameters, and even coordinate with other telescopes for simultaneous observations. It's like having robotic explorers that not only collect data, but also make intelligent scientific decisions about where and how to explore. This autonomy is already being tested in space missions. The Perseverance space probe, currently exploring Mars, uses AI algorithms to autonomously navigate the Martian surface and select interesting rocks for analysis. But imagine expanding this capability to deep space exploration. Probes equipped with AI that could explore distant star systems, identify potentially habitable planets, and even search for signs of life completely independently. Peter Worden, executive director of the Breakthrough Starshot Initiative, an organization planning to send nanoprobes to the nearest star system, Proxima Centauri believes that artificial intelligence will be fundamental to these interstellar missions. The probes will take decades to reach their destination, and once there, they will be completely on their own, with no possibility of real-time communication with Earth. They will need to be able to make autonomous scientific decisions, adapt to unexpected conditions, and maximize the scientific value of their limited observations. But the AI revolution in astronomy goes beyond data collection and analysis. Algorithms are beginning to generate original scientific hypotheses. MIT researchers developed a system called the AI physicist that can analyze experimental data and propose new physical laws to explain observed phenomena. Although still in its early stages, this technology represents a step towards machines that not only process information, but truly think about the universe in creative and original ways. Imagine a future where AI algorithms analyze patterns in astronomical data and propose new theories about the nature of dark matter, or suggest experiments to test aspects of general relativity that never occurred to human physicists. These machines could identify subtle inconsistencies in our current theories and propose modifications that lead to a deeper understanding of the cosmos. But with all this revolutionary potential, fascinating questions also arise about the future of science. If machines can make discoveries that humans never would, how does that change our relationship with scientific knowledge? How do we validate discoveries made by algorithms that operate in ways we cannot always fully comprehend? Max Tegmark, an MIT physicist and author of Life 3.0, argues that we are entering an era of augmented science, where the collaboration between human and artificial intelligence will produce insights that neither could achieve alone. Humans bring creativity, intuition, and the ability to make unexpected connections, while machines offer processing speed, the ability to analyze complex patterns, and the skill to work with quantities of data that exceed any human capacity. This partnership is already yielding extraordinary results. AI algorithms are helping astronomers discover new types of cosmic objects, such as the mysterious fast radio bursts, extremely intense energy pulses that last only milliseconds but release more energy than the sun produces in an entire day. The origin of these bursts remains one of modern astronomy's great mysteries. but AI algorithms are identifying patterns in their occurrence that may finally reveal their nature. Recapping our cosmic journey today, we discovered how artificial intelligence algorithms have already identified thousands of exoplanets hidden in Kepler. Telescope data revealed the invisible architecture of dark matter that permeates our universe, and are detecting the subtlest ripples in the fabric of space-time caused by black hole collisions. We saw how these thinking machines not only process data faster than humans, but discover patterns and make connections that our brains simply couldn't perceive. We are living in a unique moment in human history, where our ancestral curiosity about the cosmos meets computational power to finally begin answering some of the deepest questions about our existence. Artificial intelligence is not replacing human curiosity about the universe. It is amplifying our capacity for exploration in ways that our ancestors, who looked at the same stars we see today, could never have imagined. As we contemplate this future where machines and humans work together to unravel cosmic secrets, one question remains: if artificial intelligence can discover aspects of the universe that are beyond direct human comprehension, what does that tell us about our own nature as conscious beings in a seemingly infinite cosmos? Perhaps the answer lies not only in what we discover about the universe, but in what these discoveries reveal about the limitless possibilities of intelligence. Whether biological or artificial, cosmic explorers, what AI discovery in astronomy impresses you the most? Do you believe that one day machines will make scientific discoveries completely independent of humans? Share your thoughts in the comments. I love reading our community's unique perspectives on these fascinating topics. And since we're talking about the future of cosmic exploration, what mystery of the universe do you want me to talk about in the next video? Wormholes, the possibility of parallel universes, the search for extraterrestrial life. Leave your suggestions in the comments. We're on an incredible journey towards our first 1,000 cosmic explorers. If this video expanded your perspective on how technology is revolutionizing our understanding of the universe, join our crew by clicking subscribe. Like this video if it sparked your curiosity about the future of astronomy, and share it with someone who is also fascinated by the mysteries of the cosmos. In the next video, we will explore one of the most enigmatic phenomena in the universe: wormholes. Do these cosmic bridges truly exist? Could they be portals to other dimensions or shortcuts through space-time? Prepare for a journey that will challenge everything you think you know about the nature of reality. Until then, keep looking at the stars, and remember, every point of light in the night sky is an opportunity for discovery. And now, more than ever, we have the tools to transform our curiosity into real knowledge about the infinite cosmos that surrounds us.